today I'm here to tell you a story, a fairy tale. The title of the fairy tale is Advertisement Agency Meets a Cloud. But first things first, let me probably introduce myself. Let me set up myself first. Let me introduce myself. So I'm Maciej Sawicki. I'm DevOps engineer in DeepSense AI. I'm working on some machine learning tool for data scientists to make their deployments easy and reproducible, and their training process and research process reproducible. But this is not my only one activity. I also do some freelancing projects, and this fairy tale that you will hear today is a little bit inspired by some my experience. Also, I'm organizer at GDG Cloud. We're organizing meetups about Google Cloud, and I'm organizing a Kubernetes and Google Cloud workshop as a certified Google trainer. And there is here are my contact details, so feel free to contact me. And some disclaimer. So, because of some corporate stuff and so on, I haven't managed to get proper approval for this talk. So, so just think about this as, for the sake of a reason and my safety, as some fairy tale. It may happen or may not happen, and all facts are just maybe complete made up, and all similarities are random. Let's start with introducing drama characters. And we have three main drama characters. There is the company. The company is the biggest over-the-counter drugs manufacturers. Over-the-counter drugs are drugs that you can buy without prescription. So everything that you see in markets, basically this kind of stuff. And what is worth to notice is that there is one main brand in Poland that produces most of this stuff. So when you see some drugs, probably this is from the same company. However, each of these drugs has its own brand. So own logo, or own website, own brand manager, and it's developed, its online marketing is taken care independently. The second character is a Fumedica. So Fumedica is a company. It's a digital agency that is specialized in marketing for pharmaceutical companies. And they were responsible at some point for digital portfolio of the companies. Also, they were responsible for hosting of their website, and they used dedicated servers for that. And the third character, and whenever I will say my or we, let's say that this is a lyrical ego of this story, but just for a secret reason. So or is actual my client, and or is the company that the company decide that will hand over from Fumedica to all of these digital assets. And also, one thing worth to notice, or is a very big fan of Google Cloud, and they come up with idea to migrate to GCP. But before we continue with this story, we have to answer one very important question. Actually, three important questions. So, first question is what, why, and how. So let's start with what. Okay, let's see what was in Fumedica. About 40 websites. So it was about 30 different brands, each branch with different technology, different website, and about 10 other websites like general information about well-being and health. Also a few websites dedicated for medical professionals, protected by some password, and only authorized people like doctors or pharmacy employees may access these websites. And this will be important in few seconds. 260 domains. I will explain later why so many domains. And regarding technology stack, most of the stuff was in PHP actually. So I learned a little bit too much PHP during this project, much above my comfort zone. And it was very poor PHP code. So I'm not a big PHP hater, but actually this code wasn't that nice. And there was also some Ruby and Node.js. Regarding database, actually this was nice because everything was in MySQL. So we had only one technology to take care of, and it was very helpful. And regarding this PHP stuff, everything was in custom do-it-yourself CMS. There were also some WordPresses, but most of the stuff was do-it-yourself CMS without any library framework, only some templating engine called Twig. And even worse, do-it-yourself OAuth server written in PHP. So this was to protect these professional websites for only authorized medical personnel. And last thing regarding the current situation, the company controlled almost, we found out later that there was also a problem with this, but almost all domains, but they delegated name servers to Fumedica. So basically what I'm trying to say here is that the company wasn't really aware about the infrastructure. So everything was delegated to Fumedica, and the company didn't touch the infrastructure of the external websites. Of course, they had some internal stuff like email, maybe some other internal systems, but basically, besides DNS, we didn't work with the company. Okay, but why? Why we would like to make such big migration? So before we answer this question, let's make a small digression. And for those of you who are familiar with Kubernetes, you may not be aware of this concept. So OODA loop stands for observe, orient, decide, and act. And it was actually the concept by some military strategist. But in Kubernetes world, there is a special case of this loop, and it's a reconciliation loop. And basically the idea is to compare current state and desired state and make current state to be the same as desired state. So in our case, the desired state would be moving everything to Google Cloud, have reasonable infrastructure costs, and make everything operatable by the engineers and after hours. So no full-time employer for maintenance of the infrastructure maintenance. And connected with this, very easy deployments. So make it possible to deploy a new version of the website by brand manager, project manager, web designer, and so on. So ops guys, for example me, or Leo Ego of this story, would only do some work only in some crisis situations. And to answer the question, why? So one possible answer is that because for some reason the company preferred to work with our company than Fumedica. Maybe they were cheaper, maybe they were better, they provide better quality, maybe both, maybe none, I don't know. But I prefer different answer to this question. So the migration process was an opportunity to upgrade the infrastructure, to make this more flexible, more agile, simplify deployments. So the final goal was to change the desired state to having modern infrastructure. Okay, so sounds very good, but how we can do this? Well, simple plan. Let's migrate everything. Well, maybe a little bit more details. So this was some plan version 0.0.1. And of course, the first step would be inventorization, obtaining all accesses, obtaining all assets, planning, communication, scheduling maintenance window, deploying on staging, and doing actual migration, or something like that. It actually doesn't matter at all, because, well, few things didn't go as planned. And there are few problems. First of all, we didn't get any documentation from Medica. The second problem, we didn't have any even read-only access to old infrastructure. And of course, Medica was quite unhappy about this situation, so the contact with Medica was quite limited. So only what we really get was some targz dumps, and there were two types of targz dumps. One was were dumps from actually live infrastructure, and they were more useful, but there were some problems with that. So there were some broken symlinks, for example. Why we know they are for sure that they were from live infrastructure? Because, for example, they include some logs files. The second type of dumps was actually a package of a Git repository. And the story is that even when Medica was aware that our company will take responsibility of development of the website, but they were still working on some features, and they dropped us Git dumps of the newer versions. So basically, these dumps were some work in progress, and we weren't even able to turn them on, and also they were completely different than what was on live systems. And we also found out many bugs in current infrastructure. Unfortunately, we found them after the migration. And of course, it was a task for our company to fix this everything, but at some point we weren't sure if we broke something or it was broken before migration. And the last thing, no deployment scripts or anything like that whatsoever. And that wasn't that much painful. The biggest problem were outdated libraries. So, and finding all the dependencies. And some libraries, like Ruby libraries, were even removed from repositories. So it was quite hard to make everything working. And in my opinion, the biggest mistakes during this phase were two. One, we haven't done proper audit of old infrastructure. If I would do this one more time, I would hire some manual testers and just ask them to click through all websites and prepare some report. And the second thing, it was a mistake and also the biggest success. So at some point we found one person that was very helpful in Medica. It was Medica administrator, and he was a very good guy and very helpful. And actually, I think this is also his success. Like we managed to finish it because he was able to provide us missing pieces and missing files and missing informations. But we make this friendship a little bit too late. Okay, so the situation is quite bad. So what now? So one more digression related to previous digression. As the DevOps movement is about collaboration between developers and operators. That's the definition, so I have to agree with that. But my opinion is a little bit that it's a little something more in this. So if you DevOps like-minded person, I think your main responsibility is to observe current state, understand it, also observe and understand desired state, and use your all technical and also soft skills to transit from current state to desired state. And now the game world is set up, you know the situation, and we can just start talking about migration. Of course, one more thing related to this plan: automate as many things you can. And now the real story begins. There are 8 chapters, very short chapters about each migration step that we actually did after finding out that our perfect plan is not that perfect. So first step is actually step 0, set up some simple project management infrastructure. And it was very, very simple, very lean, but also very powerful. So Slack, Trello, and G Suite. It was enough for 3-person team. We used Slack integration with monitoring. We also experiment a little bit with chat ops, so some reporting from Kubernetes to Slack. Also Slack integration with Trello. All design docs in G Suite. And basically that's all about infrastructure, but I think this is very, very important step to set up something before you start working on such project. And the first chapter is GCP setup. So this would be probably another long talk, how to, some introduction to GCP, but here I would like to give you a few tips, what should you do when you're starting your GCP project. So first thing is enabling billing, because accounts with disabled billing are very limited and you can't do many things. After enabling billing, it is a very good idea to set up billing alert. And even if you don't know what the cost would be, set up it for something low. Even if you're just starting development, you know that you shouldn't have big costs. Let's say set alerts for $50 or maybe $100. It may save you some troubles in case of any mistakes. Set up accounts and permissions. So basically, basic stuff, set up roles for the users. If you use service accounts, then you probably have to think a little bit more about this to really limit access to needed services to others for service accounts. But in such small project, basically give editor or owner to all IT guys, and this should work. But just think about this before you do this, because maybe in your case you need something more advanced. And ask your team to use two-factor authentication. Next thing is deciding which region you would like to use, because in many cases you won't have multi-region deployments. This is a different scale. So since this is like some introduction, just use single region, but decide which region is the best for you, which has the smallest latency. Also, there are different hardware architectures available in different regions, so just check this yourself. And next thing is network topology. So if you use App Engine or some managed services, it doesn't matter at all. But if you use Kubernetes and also VMs in the same time, it really matters. So you have to plan your address space. You should decide if you would like to be able to connect from pods to VMs. So maybe you would like to have VMs and Kubernetes in the same VPC, or maybe you would like to prohibit this access. So maybe you would like to have dedicated VPC for your cluster and dedicated VPC for your VMs. So basically many things related to networking. Two more things. Before going live, I really recommend buying a support plan. And this actually it's now quite cheap, because Google changed their pricing model, and you can buy support per developer, like per person that can create support tickets. And it's much cheaper than it used to be, because, for example, if you have one person in your team that can create tickets, you can have a support plan only for $100 per month. And if you would like to better understand your infrastructure, enable billing export to BigQuery. Chapter 2, deploy GitLab. So, of course, we love infrastructure as a code, but this is like a chicken and egg problem, because you would like to store this code somewhere, but you first need to have some repository. Of course, you can use software as a service repository, like hosted GitLab, but if you deploy this GitLab yourself, it will work much, much better, much faster, and I definitely recommend using own GitLab deployment over the gitlab.com. But you have to deploy it somehow. And the easiest way is just set up VM and install this manually with apt-get. Installation is very simple. And this will be the central place of your further infrastructure. It's a little bit ugly that it was installed manually, but then after that, after having this GitLab instance, you can have everything as infrastructure as a code, everything using GitLab pipelines. And chapter 3, DNS. Here is haiku about DNS, and it's very, very true. So in our case, it was almost simple. But so beside these StarGZ dumps, Fumedica provided bind zone dumps of DNS zones. And it's quite nice because we can import them with just a single command, ask the company to switch DNS to Google Cloud DNS, and we won't break anything if we won't make any mistake, but we will have full control over DNS, and then we will be able to migrate traffic when we are ready. But unfortunately, there were a few domains registered by Fumedica, and we had to wait until they transferred them to the company. And also, for some domains, we didn't get these bind zone dumps, so we had to reverse engineer just using dig and guessing domain names. And to verify everything, because that was the crucial point, to make sure that in this step we won't break anything, because this was, for end user point of view, it wasn't the migration, but actually at this point we get control over the infrastructure. So to verify that these DNS are set up correctly, we wrote a simple Python script to query our DNS and compare responses with live DNS. And only after that, we ask the company to switch DNS to our servers. And one more thing, also related to this DNS migration step, setup monitoring. It's very simple monitoring. Of course, after deploying the Kubernetes cluster, you need something more. So managing logs, observability, metrics. But at this point, we needed something very simple. So something that will tell, is it up or down? And we choose Status Cake. Status Cake is a monitoring as a service solution. And the nice thing is that we were able to set up all health checks using APIs. So remember, 260 domains, so clicking 260 checks, not fun. So we set up this VR API and set up also Slack notifications. And only after setting this monitoring, we ask the company to migrate the DNS. And regarding Status Cake, well, I have a little bit mixed feelings about it. It has very reasonable prices, and it's really nice UI, nice API, and so on. But sometimes alerts are a little bit delayed, and it's not the matter of setup. It's just random, and it's not nice. But as a first thing that can give you some advice if everything is okay or not, it's a very good tool. And now the fun begins. So chapter 5, containers. Well, it was a lot of fun, and maybe there are some tools that can help to automate this, but actually we done this manually. But nice thing about containers or Docker was that we were able to work on this stuff. So work on this stuff, I mean making this website working. We were able to do this on our workstations. So we didn't need to have any staging infrastructure or any infrastructure at all at this level. we work let's say offline. We of course synchronize in our small 3-person team. We use Git for that, so we shared our Docker files via GitLab, and we set up GitLab CI pipeline for building the images. But that was only infrastructure needed to make this website working in Docker. And of course, these Dockers were quite fat containers because the application wasn't cloud native. But anyway, Docker was very helpful because of this reproducibility. And chapter 6, Kubernetes time. So in this chapter, we will set up basic infrastructure on Google Cloud to actually run our containers. So, well, this is a simple project. We can use Terraform or any fancy stuff, but we just deploy the cluster with gcloud command. Of course, we save this command just to be able that we can reproduce this and recreate this cluster. With the same way, we deployed Cloud SQL, and also we deployed NFS VM. I will explain later why we needed NFS VM. On the Kubernetes side, there was some very simple basic infrastructure. So there were Cloud SQL proxy to connecting from pods to Cloud SQL. Nginx ingress, we first consider using Google Ingress, but there's a limit of ingress rules. I think it's 50 rules, and it was we definitely needed more. Remember, 260 domains. And for SSL, we use kubelego because it's quite. We begin this project. We did this project quite a long time ago, so it was before CERT manager time. So kubelego was working well. Almost. There's one slide about this as well. And yeah, prepare YAML files, very simple YAML files, Kubernetes deployment files with deployment, service, and ingress. One Kubernetes tip, set up liveness and readiness props, of course, and resources. And this will make your cluster much more, your workloads much more stable. And why we needed NFS VMs? So few of these websites were working with disks. So for example, saving uploaded images and so on. And we needed replication. And unfortunately, cloud volumes are read-write once. So in this case, you cannot mount the same volume to multiply containers, multiply pods. So we needed something that is read-write many, and it was NFS VM. And this image of this VM was actually prepared by Google, but it's not officially supported by Google, unfortunately. But now there is FileStore, and we are planning to migrate from this VM to FileStore. And maybe now is the time to explain why there were actually 260 domains. So domains were like, let's say, for SEO or brand protection purpose. So each brand, like 30 brand, has 5, maybe 6, it depends on brand. Additional websites like .com, .pl, .wav, .pl, different ideas, .eu, .nu, whatever. Different additional domains for different websites. And how we handled that? We said for each brand we had one ingress object in Kubernetes, but we preferred different. So in Nginx ingress you can set up redirections using annotations, but we preferred a different approach to first of all have much cleaner ingress definitions, and also to have greater control. And to make this similar to WordPress deployments, because we had few WordPress deployments as well. So we would like to control everything from environment variables inside the deployment. And for this, we wrote simple Golang applications just for handling redirections, and we ran this redirector as a sidecar. And well, mission accomplished. Yeah, so when we were ready, we just moved the DNS. We already had control on this and point everything to our Kubernetes cluster. And well, basically that's it. But there is a bonus level. So what happened after the migration? So first, check our desired state. Move everything to cloud. Done. Reasonable infrastructure cost? Well, this is completely made-up story, and the numbers would be also made up. But I would like to say that total cost of ownership was reduced a few times. Operate by 2 ops after hours? Done. Easy deployments? Yes, all websites are actively developed and ops team don't have to touch it. But ops team has some other responsibilities. So, outages. Well, there are some outages sometimes. And our first outage was related to Let's Encrypt and KubeLego. So for some reason, KubeLego wasn't able to renew certificates. In Let's Encrypt, certificates are valid only for 3 months. And we found out the hard way that our SSL monitoring weren't working the proper way. So at some point, our certificate expired. And fix for that was very simple, just restart KubeLego container. And yeah, so time is running up, but this is actually last technical slide. We will have some time for Q&A. So the second outage is more complicated, and it's definitely a good topic for another talk, or maybe more than one talk. So we try to reduce cost even more by using preemptible VMs. So preemptible VMs lives up to 24 hours, but they are 3 times cheaper than regular VMs. But there is a small problem with them in Kubernetes. There were a bug. I heard that it's fixed, but I haven't checked this myself yet because we just at some point decide not to use preemptible machines anymore. This bug is probably fixed. I talked with Googlers about that also, and I will give another try to preemptible VMs. Bug is basically about networking. When preemptible node is killed and recreated again, the node is created from scratch, and there is init script is started up, and there is generated new pod seed on this node, but the node name stayed the same, and Kubernetes master thinks that this is the same node. And basically, you can schedule the pods on these nodes. That's our function in this case, because you can schedule these pods on these nodes, but these nodes are broken. Like they cannot access any other infrastructure. For example, they cannot access Cloud SQL, and this makes complete disaster inside your cluster. So first approach was adding some script for draining the preemptible nodes before they were killed, but later we decided that we won't use preemptible nodes at all. We will change that in the future. And basically that's all. That's the story.